Welcome to November 17th LeetCode challenge. Minimize maximum pair sum in array. The pair sum of a pair AB is equal to A plus B. The maximum pair sum is the largest pair sum in a list of pairs. For example, if we have pairs 1, 5, 2, 3, and 4, 4, the maximum pair sum would be the max between 1 plus 5, 2 plus 3, 4 plus 4, and the max of the pair sums would be the max between 6, 5, and 8, which would be 8. Given the array of nums of even length n, pair up the elements of nums into n over 2 pairs such that each element of nums is exactly one pair, and the maximum pair sum is minimized. Return the minimized maximum pair sum after optimally pairing up the elements. So we're giving an example here. We have basically the output is 7, which is the answer to the minimum maximum pair sum. However, how do we get that? So for instance, we could take the pairs 3 and 3 and 2 and 7, and the maximum pair sum would be the maximum between 6 and 7 that way. Given this array num here was a maximum pair sum, so the elements can be paired to 3 and 5, 4 and 4, and 6 and 2, which are all equal to 8, so the maximum between of all 8 is 8. So our constraints are the number of length is equal to n is between 2 to 10 to the 5, n is even, that's a good thing right there. So we can always make pairs, and the number of each index is between 1 to 10 to the 5. So we know we have to make pairs, and n is even. Now how do we know which pairs to make with which element here? So what are the conditions again? So say this is a sorting approach of question. So we are given an array of n integers where n is even. So we need to find a way to pair up these integers in a way such that the maximum sum of the pair is minimized. So that's a weird a way of putting it, but you're essentially looking to return the minimum maximum pair sum in the array. What that means is that if you want to think about it in a way where if you pair up the sums of smaller numbers integer together so that the pair sum is minimized at the beginning. However, in this way, we only end up with the larger pairs of integers at the end. Hence, we increase the maximum pair sum. For example, say we have the array, let's see, we have the array of 1, 1, 2, and 3. And we're given, if we were to pair this up, we would get 1, 1, and the other one would be 2 and 3. With the maximum sum as 5 being this one right here, the sum of this. However, the optimal way would be to make pairs such that it wouldn't be this pair. The optimal way to make it minimized would be, say, if we were to choose alternatives, would be 1, 3, and the other pair would be 1 and 2. And we see the maximum of that would be 3 right here. No, 4 would be 1 plus 3 equals to 4 right here. And that's the maximum sum of 4. So basically what we want is so we basically want to take the maximum sum of the minimized pair arrangement. So this would be the minimum pair arrangement, and this would be the maximum of that. So how do we kind of build an algorithm around that kind of concept? So this suggests that we are pairing the adjacent numbers by values that may not be the most optimal approach. So in inspecting this kind of example, we could think of a potential strategy that kind of pair up the numbers in the smallest integer with the greatest integers and then that would be one example, pairing the largest with the smallest, or that we can pair the second smallest with the second greatest, and so on. So basically you pair the largest number with the smallest number, and that will kind of hopefully evenly distribute it. That could be one strategy. So the method ensures that we don't pairing two greatest numbers together, as we did in this one here. So for instance, in this trial number 1 here, we paired the largest numbers together, which is 2 and 3, and that gave us not the minimize maximum pair sum. And this one, strategy number 2, we stored the largest number with the smallest number pair. So suppose we have, now let's take this and let's generalize it. So say if we have, so this method ensures that we don't end up pairing two greatest integers together, as I was saying before, but how can we optimize it such that it always ensures that we produce minimum pair sum? So suppose now, let's generalize this and we have an array of A1, A2, A3, and so on, all the way to AN, right? So where these integers are sorted in ascending order, so that we have A1 being the smallest integer, the minimum integer, and then AN being the largest integer in the array. So say we sort it first, right? So as such. So see how these aren't sorted yet? So we sort them, that's how we do it. And we kind of use the same kind of approach as we did right here, where we would take A1, pair it with AN, A2 pair with A minus 1, if that could be done right here, A and minus something like that, and we pair A3 with A n minus 2, and so on. So we pair kind of the largest with the smallest, and then keep work our way towards the middle. So yeah, that's basically it. So let's assume that we use an opposite method here. So basically kind of fold it together, and so we kind of find a way to so let's think there's also a way to prove that the counter of this will also not work, but let's kind of move upon this and see how we can go about doing this. So therefore, we will sort the integers in the array, pair them from the left with the integer to the right, the minimum value pair it with the maximum value, the next smallest value pair it with the next largest value, and so on. So we iterate over only half the first of the array, because the corresponding second element in the array can be found by using the length of the array minus the index. There is a way, so this is kind of a rough intuition of it, but there is mathematical proof for this. I'm not going to go over that. So let's kind of write out some steps to solving this algorithm. So first things you gotta do, sort the array. Next thing we should do, initialize it. I'm just gonna initialize a variable and iterate over it. I'm just gonna actually solve it instead of writing out the comments. So how do we go about solving this? So now that we have the explanation out of the way, let's say we sort the array. We could use array.sort, which is a built-in Java library. Sort the array, nums. We should initialize a variable called maxSum to initialize it to 0. Next thing we want to do is iterate over the length of nums to find the index of each length of the numbers as well. So for int I equal to 0, such that index I is less than the length of nums, we only need to iterate through half of it, because if we iterate through the first half, we will get the second half. So it's kind of right here telling us to do a division right here. And then we do increment I by 1, or increment I. So what do we do when we iterate through each element? We have to update the max sum with the max of, what are we finding? The current max element we have, so max sum we have, with number at index I plus, what are we plussing? We were plussing the opposite element at index I, which is the other n, right? So the other n of kind of the mirror opposite of the array would be nums at index, which would be nums.length minus 1 minus I. And we find the maximum sum between the current sum we have and the addition of the largest and the smallest number index-wise. And then we iterate through that, return max sum. Alright, let's take a run at this. Make sure everything is okay. Run the code a bit. Arrays.sort nums. Whoops. It's arrays. That looks pretty decent. Sweet. Runtime is pretty low and memory usage is pretty low as well. Why is that? So here, let's do some complexity analysis. Time complexity is big O of n log n. So we only iterate through half of the array, and so we're sorting the numbers by the array, and it will take n log n time to sort it, actually. And then we iterate through each element of the array, which will take n times, so it'll be n times log n. Memory usage, we don't need to store anything in extra space aside from basically this function right here. This method right here to sort it. Space complexity of the sorting algorithm depends on the implementation. If we use arrays.sort, we know that the space complexity of that is basically O log n. But it depends on the sorting algorithm you use. And this one stores it at log n. Alright, that's it. Have yourself a nice day.